let's begin. All right, grab out a pen or pencil. Let's write a couple of notes here, team. Pseudocoding. There are two things. Settle down. Two things that you need to know. When it comes to pseudocoding, you do not need to know how to write the code. You don't need to know how to write the code. You do need to know two things. One, you need to know how to read the code. So you don't need to create or write the code. You need to know how to read the code. And then two, you need to know how to compute mathematically or even understand the rule. Compute or understand the rule. So only two parts. So essentially it's comprehension. That's what it simply is. So what I'm going to go through, just a couple of pages and there's some practice questions. Most of the guide is pretty self-explanatory. So even without me sort of going through with you, you can probably figure it out as you read through it. You just need to be able to, once they give you a set of codes in the exam, so if it's a multiple choice question, you just need to be able to follow the code and then figure out what formula it is. So let's say if it's a Newton's method problem, or whether it's a trapezium rule, or whether it's just simply an algorithm, what would the final answer be? That's what you need to be able to do. Okay? So let's do a couple of things. Let's define and understand the language of coding. First one, the algorithms follow from top to bottom. So each entry of a line, it follows sequentially. So it always goes from top to bottom. So one line at a time. So one line at a time from top to bottom. That's how the language is spoken. There are some notations. So we're going to start off with the first one. A variable. It is named in the computer's memory to store a data, okay? And what it simply means, and notice the arrow is pointing towards the left there. So it's from the right to the left. And what that means is you're taking a value and you're substituting. So the key word there is substitution. You're substituting a value for the variable. Now, from our understanding of variable, it's a letter. Okay, so the way you think about it is letter that can change. So instead of saying things like where you normally have to type in declare the variable, so how we normally do in our CAS is we say define f of x, right? So this would be declare integer n. So the letter n now represents a number. And then on the bottom it says then set n to 0. Well, then instead of doing that, you can now write variable n, left arrow. We're wanting to set n to be 0. So essentially this means set the integer n to 0. Okay, so this language here is saying set integer n to 0. So far straightforward? Yeah? Just like storing on your calculator, you might take a number and then you store it into a letter. Well, it's just written the other way around. So n with this map, that just means set integer n to 0. Okay, so that's called an assignment operator. Let's flip over the page and let's do some examples so you get used to reading and what can work and what doesn't work. There are some print errors, so I'm going to tell you to fix certain things here. Flip over the page, notice some errors. Anyone see some errors of what I just said before? What are some errors on this page? Anyone see it? Where? Third one? Fourth one? Fifth one? What's wrong with them? Very good. And based on the computer language, you normally put number into variable. It doesn't make sense to put a variable into a number. Okay? So there's arrows there. If you want to help yourself to remember, it's actually meant to be the other way around. Let's change that. Cool. So that's just some small typos there. But let's read each one. So the first one makes sense. First one is set integer y to 0. Fair call. Next one, set 10 plus 2. So you're following BODMAS now. 10 plus 2, which is 12. 12 times 3, 36. So you can either read it as set integer y to 36 is what you're saying there. Or you can be reading it as 10 plus 2 times 3 into y. Okay? Pretty self-explanatory. Notice that because we said it goes from top to bottom and each entry is itself, this one is saying set the integer b. So if I had 2 columns here, set b to be 3, and then set c to be 3 plus b. So right now, what is b? B is dependent on what it was before this entry. Okay, it's going to be key because once you have multiple entries, you follow it vertically down. Okay, so in this case, it would then be 3 plus 3, and C would then essentially be set to 6. Okay, so that's the language. You're saying make 3B, and if you put C, the next one is make C, integer C, set it to be B plus 3, whatever B was before. Cool? All right. What about this third one now? What does this mean? Can I please have, let's go with Samuel. What does the third one mean? So I've done the first 3 examples. What's the fourth one?
You're setting x to be minus 2.
That's it. So another way of thinking about it is you either set, so you can read it as set integer x to 30.0 minus 2, or you can read it as set integer x to 30 minus 2, which is 28. Okay, so far so good. What about the next one? Fifth one. What does this mean? Who wants to have a go? Rango.
Well, it's probably just set x to equal 2. X to equal 2, right?
Well, this is a problem. So,
Wouldn't it set wouldn't set 4 to the variable x plus 2? Like there'd be a variable called x plus 2, and you've got to set it back to 4.
that's right. So this is the problem here. When we say this technically, based on the pattern that we've been doing, it would be set the variable x plus 2 to, so I should write it out. Set variable x plus 2 to 4. But x plus 2 on the computer coding, that doesn't make sense. Because a variable is a letter. It's an expression. Oh, sorry. Well, an expression can have a plus 2, but it can't have a number in it. So this one is broken. It's not possible. Okay, so this is not possible to do. Not possible because x plus 2 is not a variable. Whereas the last one, which is what we're trying to contrast here. Oh, I'm running out of batteries. Give me a second. That you can do. So let's do, here we go. I'm going to pause the video. Oh, Dan was paused. So check our answers. What did I write? I did vertical, so if it looks a bit different to yours, doesn't matter. I just prefer vertical, that's me. Y is negative 3. X is negative 6. Next one. Looks like I've got y and x variables as well. So 0.4 for y divided by 2. So that becomes 0.2 for x. Take x, put it into y, so it's 0.2. And then x is the new 0.2 plus 5 is 5.2. Hands up if you got the first 2 correct. Good. So far so good. Next one. I've got a variable y, I've got variable x. Negative 3 plus 2 is negative 1. X then becomes negative 1 plus 2, which is 1. Then take x to replace with y. So x is now 1, y is now 1. And then x will be 1 minus 6, which is negative 5. So far so good. Last one. You got 3 variables now. So there's a z, x, y, z. So you started off with 1 for x, 1 for y. Z is x plus y, so that becomes 2. Then x now becomes whatever y is plus z. So y plus z is 3. And then y becomes x plus z, so 3. and z is x plus y again, so then becomes 6. That's pretty straightforward. Hands up, we got all of them correct? Oh. Did I read wrong? Where did I go wrong? Second last one. Y is x plus z. I was doing x plus y. That's true. So y is x plus z, 3 plus 2. Thank you. That is 5 and then 8. My bad. My notes were correct, and yet I did it wrong. I must have looked at this x. All right, let's flip over. Let's flip over Boolean expressions. Boolean expressions are statements that are either true or false. If it's true, keep following the instructions. If it's false, you follow on to the next line. So that's the key thing. If it's true, stick to what they tell you. Thanks, boys. If it's true, stick to the instructions. If it's false, that's when you move on. That's when the else comes in. Okay, so if statement, whatever the condition is, check if it's true. If it's true, follow the instructions. If it's not true, you move on. If it's not true again, you move on. So if it doesn't work for the first one, go to the next one until you find a truth. Okay, so once you find a true, then you're done. Here we go. Let's have a look at an example here. Starts off with make variable x or integer x 10. So I've got my variable, my vertical column, x is 10. If x is greater than 20, then you now, if it's true, so in this case, it's not true. Currently x is 10, so not true. If it's not true, you move on to the next instruction. If it's not true, then x minus 2. So 10 minus 2 gives you 8. And if means you're ending the final part of that condition. Print means what is the final answer? Final answer for x is x divided by 2. So that's why it's 8 divided by 2 here. And your final answer is 4 is what you'll see. Okay? Let's do this one. Variable z. So I got a variable z. Z starts off as 20. Condition is, if z is greater than or equal to 30, you follow the instructions. Currently, it is not, so it's false. Move on. It's not greater than or equal to 30, so we move on to the next one. So therefore, take whatever the number of z is, plus 20. That gives me 40. That finishes the condition. What's my final z value that I want to see? It's take that number divided by 4. So 40 divided by 4. That's my final step. Okay, so I should see z is 10. You ready to practice? That's your Boolean expressions. It's a true, if not statement. The next one could be a bit tricky. Take your time. Flip over. Think about what I said. Follow it vertically. Tell me, what does A and B end up being? What does it print out to be? Be careful. That's with C.
Yeah, that doesn't look wrong.
How many of you had 36? How many wrote 36 here? Eyes used towards the board. Okay, be careful. This is what I mean. So with all these conditions, listening? Alex, thanks. So first thing to note, all these else ifs is to distract you. If the first condition is true, that's done. You just do the first one. That's how the computer works, right? So the first one, is the numbers A greater than 20 and less than 50? Yes, they are. It is greater than 20 and it is less than 50. So this is what you do. So 32 and 42 has already been set in red. And then A will be whatever B is plus 2. That's what you're going to replace A with. So 42 plus 2 gives you 44. So A is now 44, no longer 32. Next one is then say, for B, I want you to set A plus 4. Common problem is that they would take the 32 and add 4 and you get 36. Okay, but we already changed A. We said A is now 44. So therefore should be 44 plus 4 and you get 48. Hands up if you got 48. Well done, very good. And then some of you, if you did get there, but then you followed on and then you went to this one, then that is wrong. You already finished the condition, stops there. So print A and B. A will be 44 and B will be 48. So far, so good? Sweet. All right. So that's the Boolean expressions, true if statements. And your last one for today, loops. This is pretty straightforward. There are a couple of types of loops. I'm going to do the while loop. And then you can have a go with this loop. And then the one in the back. Here we go. So loops means you do something up until you reach your final destination. So in this case here, you have for a variable from, and then they'll give you an interval. Okay, so from 1 to n, for i's, follow these instructions. Okay, so that's a simple loop. Here's the simple loop. So for I, so that means I'm starting with the variable I. From 1 to 5 is my interval. What's the instruction? I want to print answers for I squared. So from 1, so when I is 1, 1 squared is 1. When I is 2, 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. And that's a loop. It will do the same one code and it will repeat itself all the way through. Rather than typing it each individual code, you can do a loop. Okay? Whereas the word while is a condition. You throw in a condition. So in this example, x, you start off with 0, and the condition is while x is less than 3, so if the number for x is less than 3, so that's the condition, then you will follow these instructions up until it's not true. Okay? So what's the instruction? You're going to add x plus 1 and replace it with the new x up until the condition x is no longer less than 3. So that means you get 0, then you add 1 to it, becomes 1. Add 1 to it, becomes 2. And if you add 1 again, it becomes 3 now. That's not less than 3. So it stops. Stops here. Okay, so this is a loop, and it's one code, and it continues until it stops. Right? This one's a combination of the two. I want you to take your time, look at their variables, have a go with this one. I'm going to pause the video for you. 3, 2, 1. Did I write the answers already? Oh, I didn't freeze the screen before. All right, team. So we can see there are 3 variables: x, sum, and y. So I just wrote 3 columns to start off with. They said that x is starting off at -2, so I start off with -2. They gave me sum, which starts off at 0, so I wrote 0. And then the key part is the condition. So while x is still less than or equal to 2, you will follow these instructions. So whenever x does not follow those instructions, or is not less than or equal to 2, you don't follow the instructions anymore, and it stops. So starting off at -2, yes, it's less than or equal to 2. So the instructions are times x by itself, or square x to get y. Square of -2 gives you 4. So I got 4 over here. And then it says, for sum, you're going to take the current sum plus y. So 0 plus 4 gives you 4. And then you follow on with the next new x value x plus 1. So really, you should expect that the x column will eventually be -2, -1, 0, 1, 2. That's the idea. It's because you're always going to add the last bit. You're going to keep adding until you reach the very last condition. So if I follow that pattern, -1 squared is 1. So that means the next one is current sum, which is 4, plus 1. That gives me 5. And then I move on to the next one. X is 0, 0 squared, 0. 5 plus 0, I get 5 again. Plus 1 to the last x, so 1 squared is 1. Then you put in the sum. So it'll be 5 plus 1 gives you 6. And your final one is x plus 1 gives you 2. And that still fits the condition. So you do your last instructions here. You can see the last instruction is 2 squared is 4. So then now you have 6 plus 4 gives you a sum of 10. But then if you do this one extra step now, if x is 3, condition breaks. If condition breaks, you stop there, print sum. So what is the sum? 10. Okay? So far so good. That's pretty much pseudocoding. On the next page it's functions, which is pretty straightforward, similar to what you've done on your CAS. You should be able to work through that without me at that point, but that's today's lesson. That's on pseudocoding. You just need to be able to read and compute. Okay, I'm going to stop the video.